Hey, this is Derek, and this is section 10.1, Reducing Algebraic Fractions. And so this is just going to be a short little introduction to rational expressions in this chapter. We'll look at simplifying fractions and then the four operations: adding, subtracting, multiplying, dividing. And this will be with an algebraic fraction versus just a numerical fraction that we've seen before. And for a fraction to be algebraic, it basically just has to have a numerator and a denominator with polynomials in them, and there's an algebraic fraction. The first thing we're going to look at is domain of an algebraic fraction. And remember that domain was the set of the allowed x values. So it was all the stuff we could put into a function. And so when we're looking at rationals, which is another name for fractions, when we're looking at rationals, the issue is if we have something that makes the denominator 0. Because remember, if we have something, 3 divided by 0, that's undefined. We can't have a 0 in a denominator. And so to figure out what the domain is, the way they'll ask the question on the homework is, what is the only value not in the domain? So they're asking you to solve for sort of the undefined value rather than state the domain. All we got to do for that is just take the denominator and set it to 0. And then here I would just subtract the 2 on both sides and solve, right? So x equals -2. So -2 is the one thing x can't be. So that would be the only value of x that's not in domain for this one. For this one, we would just, again, set the denominator to 0. It doesn't matter what's down here. If it was quadratic, we'd set it to 0 and factor. Bring this over and divide. So for that one, x can't be 7/6. So that's the one bad number. Okay, so next up is reducing algebraic fractions, and the basic steps for this are super simple. We just factor the numerator and denominator of the fraction completely, and we cancel the common factors. And that's what we've been doing for reducing fractions all along. I'm going to remind you one here with just numbers and then kind of head into the examples. So 10 over 15, what we do a lot when we do this, when we run into this, like just in the homework, we kind of go 5 goes into 10 twice, and then 5 goes into 15 3 times and get our 2/3 that way. If I wrote it out a little bit more formal, I could think of this 10 as 2 times 5, and that's the factoring piece. I could think of 15 as 3 times 5, and then I can cancel the common factor, which is the 5s, and that makes 2/3. And so basically, if you can write something as factored and then you have something common, it is okay to cancel. And if you can't, then it isn't okay to cancel, is the other side of it. And so these first few examples are getting at when it is okay to cancel and when it isn't okay to cancel. And the answer is, if multiplication, division, you can cancel. Addition, subtraction, you can't cancel. So right here we have 7 plus 3 over 6 plus 3. And they're asking which of these expressions here is equal to 7/6. And so basically they're just saying, hey, can we cancel the 3's or not? And this is a no, we can't cancel. This would really be 10/9, right? Because we would just add the numerator and denominator, and that would be it. So this is a no. This one, 3 times 7 over 3 times 6. So that's just like what I have here. That is factored, and there's a common factor, 3. So that is the same thing as 7/6. This one might be a little confusing. It's 7 divided by 3, 6 divided by 3. And it's like, well, does that still work? And it does. And you can think of it as 7 times 1/3 over 6 times 1/3, because 7 divided by 3 is the same thing as multiplying by 1/3. And then I do have a common factor of 1/3, and there's our 7/6. A few other ways of looking at it, but there's one. And then 77 over 66, if I factor that, 7 goes in 11 times, 6 goes in 11 times. And then I have common factors of 11, so it equals a 7/6. So you can always cancel when you have multiplication or kind of the rare division, because you can rewrite it as multiplication. You can't cancel when you have the addition or subtraction. So here, reduce the fraction if possible. This is 3 times x and 5 times x, so that is written in this form, right? It's multiplication, so I can cancel the common x's. This x plus 3, x minus 7, can't reduce it because, again, addition and subtraction. And same thing here, x plus 5, y plus 5. Those 5's might be tempting, but you cannot do that. If it was times, you could, but with addition or subtraction, you cannot. Okay, so then here's what that will look like with a little bit more algebra in the algebra. So we need to factor first and then cancel. X squared minus 9 is going to factor to x plus 3. And then x minus 3. and that denominator is x plus 3. And so then hopefully you can see right there we have a common factor of x plus 3 in the numerator and denominator. And so reducing leaves me x minus 3. So that would be my reduced form. For this one, again, be careful that you factor. It's really tempting to just kind of knock out those x's and go x squared, but that's not factored, so it's not legit. I can factor an x out of the numerator, which means now I've written it as multiplication, which means it's okay to cancel. So now I can say I have common x's in the numerator and denominator. So that's going to leave x plus 1. The other way to think of that one would have been x squared over x plus x over x. And that x, when it's just a single term down there, you can do like we did back, I think it was chapter 5. Here, x squared plus 49 is really tempting to try to factor, but remember this is prime. I cannot cancel across addition, and so this is not possible. This is prime. That's as far as it reduces. Okay, for this next one, looks like in the numerator I can factor out an 8, so I'll do that. And I believe a 3 there. And then for 40, since I have that 8 out front, 40 breaks up a lot of ways, but I'm going to go 8 and 5 because it's going to be convenient. And it's going to allow me to cancel those 8s. And then r plus 3 over 5 would be my result. If you have not yet discovered, I've said this a million times now, I'm sure everyone's discovered it, but that little yellow arrow in the answer box, there will be a fraction template, and that fraction template will make typing these things so much easier. That said, going on to the next one, factor cancel, right? So what multiplies to be negative 10 and adds to be negative 3. So we'll set up our parentheses and we'll do our x's. So negative 10, I got mixed signs, so we have positive and negative. 1 and 10 are 2 and 5, and it looks like it has to be 2 and 5 to get that 3. And the 5 is going to be the negative because the 3 is negative. Then downstairs multiplies to 6, adds to be negative 1, so it sounds like x minus 3 and x plus 2. I cancel the x plus 2's, and then I'm left with x minus 5 and x minus 3. And same thing on this last example. We're just giving two numbers that multiply to be 9, add to be negative 10. So that would be x minus 1 and x, minus, sorry about that, 9. And then downstairs we have a difference of squares. So that's going to be a plus b, a minus b, or x plus 1 and x minus 1. So minus 1s are canceling, and x minus 9, x plus 1.